Good
Good
day,
day,
viewers,
viewers.
and you are welcome. How to solve these logarithm equations, exponent simplifications, given this. So here, which is 3 being the smallest base, and which we can express this 27 as the base of 3. So let's do that. We have this as 3 to the power of 3, and here, which is log of x, we close bracket and we write log x plus 3 to the power of log x equals 68. And so here we have 3 to the power of 3 log x. By considering this rule of exponents, when we have a to the power of m all raised to the power of n, we can also have it as a to the power of n all raised to the power of m. By applying it in this, which means you can switch this one and it becomes 3 to the power of log x all raised to the power of 3 plus 3 to the power of log x, and by taking this one here we have minus 68 equals 0. Here we have 3 to the power of log x and this another 3 to the power of log x, which means I'm gonna let this to be another letters for easier simplifications. So we have y equals 3 to the power of log x. By doing the replacement, we have y to the power of 3 plus y minus 68 equals 0. If this is a cubic equations, we are going to find the value of x for this. But what we do is, we have this 68, which you can rewrite it as minus 64 minus 4. And here we have y to the power of 3 plus y minus 64 minus 4 equals 0. So we're going to rearrange this. We place this 64 beside y to the power 3 and we combine this y and negative 4 together as well. And here we have y to the power of 3. So about this 64, we can write it as 4 to the power of 3, which is still 64. And I'm going to bracket this plus, again we have y minus 4 equals 0. Here, which is y to the power 3 minus 4 to the power 3, we can also write this thing as, when we compare it with this identity, a to the power of 3 minus b to the power 3, this equals a minus b, bracket, here we have a squared plus ab plus b squared. So here is the identity we are going to apply for this. If a is y and b is 3, is 4, so we have y to the power of 3 minus 4 to the power of 3 equals y minus 4, bracket, open bracket, y squared plus 4y plus 4 to the power of 2. And here, which is this, and we still have this, so let's place this together and we have y minus 4 bracket y squared plus 4y plus 4 squared plus y minus 4 equals 0. So here are together and we still have this. So which means we have something that is common to them and it is y minus 4. By factoring out y minus 4, we have y minus 4 and here we are left with y squared plus 4y plus 4 squared, and 4 squared here is 16. So by taking this one out, we are left with plus 1 equals 0. Again, we let this y minus 4 equals 0 and this equals 0. So therefore, y minus 4 equals 0 and y equals 4. So with this, y squared plus 4y plus 17 equals 0. We know to obtain the value of y here, when you consider the discriminant of this, if the discriminant is given as d, which is b squared minus 4ac, and from here a is 1, b is 4, and c is minus 17. By plug it in this, we have 4 squared minus 4 multiplied by 1 multiplied by 17. So the whole of this will be negative. So which means discriminant less than 0. And when discriminant less than 0, it means we get a complex solutions. So we neglect this and we work more on y equals 4. So if y equals 4 is not the solution, so what we need is the value of x. And from where we let y equals 3 to the power of log x, we are going to substitute the value of y, which is 4, to that. And here we have 3 to the power of log x equals 4. So we need 4 here. What we will do is, let's introduce logarithm of base 3 to both sides. By doing so, we have log of base 3. Then we have this as 3 to the power of log x equals logarithm of 4 base 3. So by the properties of logarithm, this log x will come to the base and the logarithm of the same base equals 1. Therefore, we have this as log x equals log 4 base 3. And with this one, suppose I let this one having base of 10. So if this is having base of 10, so which means I'm going to introduce logarithm of base 10 to both sides. So the final answer for this one is given as x equals 10 to the power of log 4 base 3. So we have this as the value of x, as the real root for the value of x. And we can indeed check if this is equal or not equal. And from the question, which is 27 to the power of log x plus 3 to the power of log x. And since we have gotten the value of x, which is 10 to the power of log 4 base 3, so we try to do the replacement with this one. And here we have 3 to the power of 3, which is still 27. And here we have logarithm of, so x here is 10 to the power of log 4 base 3 plus 3 to the power of logarithm of, here is 10 to the power of log 4 base 3. So with this one, if we have this as log 10, and by default, if this is also in base 10, this is also in base 10. So it means logarithm of the same base equals 1. So this equals 1, and this log 4 base 3 will come down. Here we have 3 to the power of 3. So we have log 4 base 3 plus 3 to the power of log 4 base 3. So by taking this 3 to the power of 4, we have 3 to the power of log 4 raised to power 3 base 3 plus 3 to the power of log 4 base 3. I want us to know something here, that let's say we have x to the power of log y base x. The result of this is y. So here we have the base of 3 and we have so which means this cancelled and we have 4 to the power of 3. So 4 to the power of 3 here is 64 plus, again this we cancelled, so we have 4 plus 4. So which means 64 plus 4 equals 68. So which means that the left hand side of this equation equals to the right hand side. And as usual, we are done. So thanks for watching, and please don't forget to subscribe to this channel and like this video and turn on the notification bell for more exciting math content like this. I will see you in the next video. Never stop learning. Bye bye.